So we modeled some floor slabs. Let's understand what we're looking at in a building section. All right. In my handouts folder, there's a PDF with this study. Assuming everybody knows where to find these things. So we're looking at a building section. We have to think about two. What do I need to prototype? What do I need to demonstrate to show what I'm doing? Right? We modeled 3 floors, level 1, level 2, level 3. And I'm just going to identify those floor slabs with a rectangle. What I called level 1 is actually not at street level, but here. So that's the floor level. I haven't drawn it correctly yet. It's about there. Okay. I'm ignoring these trays, these sort of multi-level. That's level 1. Then level 2 is modeled here. Remember, we left the middle area open. And then level 3, finally, remember we cut out that open to below dome. That's what we're calling level 3. What we haven't modeled is the roof. For all intents and purposes, when I model the roof, I could simply create a flat plane there. We got to remember, we're not landing somebody on the moon. We're not reconstructing the building. The building exists. So do I have to concern myself with the attic, about the space beneath the gables, you know, the pitch roof up on the top floor? What I do need to know is the relationship between level, well, first at the street level, right, at grade. So I'm going to model a site plane, which I can do with a topo surface in Revit using the site tool. Just simply model 4 points at elevation 0 or wherever you need that to be. And then we have to locate elevationally the distance between each floor. Even if we don't model the stairs that lead to the different levels, elevationally, the difference between the floor levels envelope the space. The ceiling height is a really important element of the experience of being inside that building. So we have to think about that's all we're trying to prototype. So I need a strategy for, and if I'm not occupying level 3, the 3rd floor, I don't need to bother with it, right? So how can I measure this elevationally? Well, I need a copy of this drawing in the Revit model, scaled to my reference planes, so that I can measure the distance between Dartmouth Street and what I'm calling level 1 and level 2, level 2 to level 3, level 3 to the roof. I need this image. So let's all these errors with let's stop annotating. here, all my drawings, close this stupid thing. Close that. One of these images is that page. Have I identified it? Let's take a guess. That's not it. Okay, let's count the pages that I've exported this to a series of images. So let's see what page it's on. Page 9. 9 and 10 are going to be useful to us. So let's close that. 9. Hey, dynamite. Let's rename that. Building section image from I'm going to bring that into Revit Architect, into elevation. Do that with an image in elevation, I think so. The section. Let's cut a section. View. Section. Okay. We're looking that way, right? Yeah. It's a huge building, so the section marker looks tiny. Go to view. Let's expand. View. See our section planes there, which we can make. Our reference planes, which we can make large. Extend reference plane. It just propagate in all the directions. So I want to look at this in the context of that building section. I haven't drawn the street, and level 1 is at 0. So we could call the street 0 and then change the elevation to bold those guys, right? I think that I may have done this work already because I see that the difference between levels. Let's see if I can insert an image into. Not that image, it says somewhere. There it is. All right. So that's what I need. And I need it to be scaled. How do I scale it? Well, I have my reference planes, right? The distance, let's measure. Annotate. Distance between the 226 feet. That needs to be. And what is that? What does that define? That's the outside of my outside boundary of the perimeter, the walls, right? So I'm going to select this image and use the resize tool. Where is it? There it is. To say from here to here is not 119 feet as it's reporting, but it's 226 feet. 6226, enter. And that scales my image. All right. Now I want to move it so that it's within my reference planes. And align the floor levels. Okay. There's that the first floor that I drew, there it is. The second floor is not quite right, so I'm going to take level 2 and move it down because I created the floor on that level. See how it's starting to drop in? Those big openings. That's an open area, right? Where all these stairs are that we saw. And level 3 is way up high over here. And remember, we opened up the area for stairs and the big dome we see there. So now elevationally, the floors appear to be in the same place. They're probably more massive than 12-inch floors that we've drawn. So I could modify the properties of the floor. Let's select all instances of that floor. An entire project, why not? There should be only 3. I'm gonna make it 24 inches. Edit type, duplicate, generic 24. It adds a 2 because it anticipates that you want to rename it. Edit the structure and make this 2 feet. And floors are drawn up to their levels. Right, so in other words, the change I just made is propagated downward from the level elevation line. So we don't have to worry that, okay, now the floor is thicker, the elevation has changed. Let's draw another reference plane in this view. And notice the reference plane is drawn from the architecture menu because it's a thing with thingness. It's a 3D element. So I'm basically drawing Dartmouth Street. I could name that plane, right? By clicking here. Dartmouth. Grade level. So I know if see it automatically, it infers the inferred dimension that I'm getting here is to level 1 from Dartmouth Street. It's 5 feet 4. So I could draw another level. I could maybe, let's do that. Draw another level, we select level, right click, say create similar, and draw one. We'll snap to the reference plane. It's creating level 4. I don't want it to be level 4, but let's not worry about that now. And we might as well draw the underside of the roof and the top of the roof. Now, I'm not drawing any geometry yet. I'm just identifying the elevation points. Right. So let's give these some elevation bullets some more meaningful names. That's going to be top of what do you want to call that? Attic, underside of roof, underside. You could call it top of that big dome. Who wants to model that? I don't. That's where we need Crossy, he can model anything. Some things I just don't have patience. And this is going to be grade. Grade meaning street level grade is -5 feet 4. We could set relative elevation marks, and that's beyond what we want to do here. Let's just say level 1 0. So, how does that help us? I could now take, let's say I want to occupy level 3. I could take my floor, copy my floor that's on level 3, and paste a line to selected level. I paste it to the underside of the roof. So now it forms the shape. It's not the right shape. It's bigger than it needs to be, right? The front is not open to below now because it's forming. So, but if I go to a 3D view, again, default 3D view. Right, so really, I've created the building in terms of its floor slabs. Now it's just the problem of creating the walls that enclose it, and the column, the columns, vertical, other elements, interior elements, and interior walls that exist according to the plan drawings. So that's a different problem. But now I've set up the. Let's do one more thing. Grade elevation is -5 4. Let's make it an even -5 4. And I'm going to go to my site plan and model. So I'm just dealing with the horizontal phenomena of the project here. I'm going to go to my site, massing and site, topo surface, and that elevation is going to be -5 4. And I'm going to draw 4 points outside all my markers. Now, it doesn't look like I did anything, but let's go back to my 3D view. You can see that I created a surface, right? That's 5 feet 4 below level 1. So if I look at my section, right, that surface is actually, it creates this earth stuff. Now, what about this stuff below level 1? Well, if I were going to model that, I'd have to create what's called a building pad, which is excavates the area that you don't want the to occupy, but if you're not worried about that, we don't need to present that. Now, there's some relationship between street grade and the courtyard, what's in the courtyard. Maybe that the sunken area in the courtyard corresponds with that. That would make some sense. We can deal with that separately. For now, here's what we got in 3D. Okay, so the next level will deal with lessons in creating the enclosures, and then the interior elements, walls, columns, etc.